Probably one of the best giggles I've had in the past couple of weeks was when this was sent to me. On January 2nd, the Minor Planet Center at Harvard-Smithsonian Center for Astrophysics in Cambridge, Massachusetts, announced the discovery of an unusual asteroid, designated 2018 CN41. First identified and submitted by a citizen scientist, the object's orbit was notable. It came less than 150,000 miles, or 240,000 kilometers, from Earth, closer than the orbit of the Moon. That qualified it as a near-Earth object, NEO, one worth monitoring for its potential to someday slam into the Earth. I know, you're thinking, what's so funny about a near-Earth object? Less than 17 hours later, the Minor Planet Center, MPC, issued an editorial notice. It was deleting 2018 CN41 from its records because it turned out the object was not an asteroid. It was a car. To be precise, it was Elon Musk's Tesla Roadster mounted to a Falcon Heavy upper stage, which boosted into orbit around the Sun on February 6, 2018. The car, which had been owned and driven by Musk, was a test payload for the Falcon Heavy's first flight. At the time, it received a great deal of notoriety. I think we even covered it in a fun fact, as it was the first production car to be flung into space, complete with a suited-up mannequin in the driver's seat named Starman. The case of mistaken identity was resolved swiftly in a collaboration between professional and amateur astronomers. But some astronomers say that it is also emblematic of a growing issue: the lack of transparency from nations and companies operating craft in deep space, beyond the orbits used by most satellites. While objects in lower Earth orbits are tracked by the U.S. Space Force, deeper space remains an unregulated frontier. The space world never fails to supply the curious with new wonders, even here on Earth. So what is this? It's actually Mars on Earth. This barrel-shaped chamber is helping researchers to replicate weather patterns on the red planet. Their dirty under-vacuum simulation testbed for icy environments, known as DUSTIE, replicates atmospheric conditions on other planets, in this case the carbon dioxide ice found in Mars' southern hemisphere. NASA scientists used the chamber to recreate smaller versions of the spider-like cracks in the planet's terrain that were first discovered in 2003. Researchers have long suspected that carbon dioxide ice helped to create these features. The DUSTIE experiments support this idea, suggesting the soil on Mars absorbs heat from the sun, causing the carbon dioxide ice above it to turn directly into gas. This process causes the ice to crack in the characteristic spider patterns. Here's a picture of the result from DUSTIE. The closer we get to Mars, the more amazing and unusual the planet becomes, perhaps beyond even the most imaginative thoughts of science fiction writers. This high-rise image shows different dark shapes and bright spots on sand dunes in Mars' North Pole region. The bright spots are where frozen CO2 sublimated into gas and erupted, spreading darker material on the surface. Some of Mars' CO2 geysers erupt and create dark spots as large as 1 kilometer across. They are fueled by considerable power and can erupt at speeds up to 160 kilometers an hour. Earth's H2O geysers erupt at around 60 kilometers an hour. Like what the DUSTIE chamber attempted to recreate, this NASA Mars Reconnaissance Orbiter image, acquired May 13, 2018, near the end of winter at the South Pole of Mars, shows a carbon dioxide ice cap sprouting spiders as the sun starts to warm the area in the Martian spring. I'm using the word warm relatively speaking. The South Pole of Mars warms from minus 150 Celsius to minus 130 degrees Celsius. Here's another closer look at these beautiful geological features. The process that explains how the CO2 cycle creates these features is called the Keiffer model. Hugh Keiffer was with the U.S. Geological Survey when he and his colleagues published a paper in 2006. They proposed that the seasonal ice cap forms an impermeable, translucent slab of CO2 ice that sublimates from the base, building up high-pressure gas beneath the slab. This gas levitates the ice, which eventually ruptures, producing high-velocity CO2 vents that erupt sand-sized grains in jets to form the spots and erode the channels. So far as I know, until further discoveries prove otherwise, in our solar system only Earth and Enceladus have some sort of geysers. I will have to be content with my up-close encounters with Icelandic geysers until perhaps 2035, when hopefully some up-close and personal views from the Mars astronauts are returned to us here on Earth. Who knows, maybe someday there will be tourists heading to Mars. Elon Musk thinks there will be.